Hey, welcome to the third part of this lesson. Okay, so for this one, notice transformations, we have a plus 3, which means C has a plus in front of it, so then it's going to go to the left. Okay, so we say left 3, and then D, this is the D value. D is negative, has a minus in front of it, so then the graph goes down that many units. So in this case, 5, down 5 units. And also notice we have the value of A is a fraction, so it's in between 0 and 1, which means this is a vertical shrink, okay? So then the last transformation that I'm going to list is vertical shrink by 1/2. Okay, so this is part 1. Part 2, let's graph it. So before we graph it, let's copy the table of values from the parent function. So this is the table of values for the parent function, but then we're going to take into account the fact that the value of A is 1/2, which means you multiply the y values from the parent by 1/2. So 1/2 of 2 is 1, 1/2 of 1 is 1/2, 1/2 of 0 is 0, 1/2 of 1, 1/2, and 1/2 of 2 is 1. So then I'm crossing out this column, okay? So then from the origin, let's go to the left 1, 2, 3, and then down 1, 2, 3, 4, and 5. So now we go from this point. From here, if I go left 2, up 1, so left 1, 2, up 1. If I go left 1, up 1/2, so about right there. And if I go right 1, up 1/2. If I go right 2, up 1. And then connect those points. And this is what graph looks like. So notice that if A is a fraction that is less than 1, but more than 0, the graph gets flat, okay? So it gets flatter. So now let's do domain. But again, domain does not get affected by the transformation, so it's going to be all real numbers all the time. The range, however, will depend on the value of D and also if the graph opens up or down. So then for this one, y such that y is the value of D is -5. Okay, from -5 the graph opens up, so greater than or equal to -5. And there we have all 3 parts for this problem. Number 6. For number 6, we have, if it helps you, rearrange it. Okay, so I'm going to rearrange this. This is a D value, so that I have it in a way that I'm used to seeing it. So absolute value of x minus 2, and then that one is implied to be positive. Okay, so then you can see the value of A is a -1. This is x minus, we have a negative in front of C, so that means if it's negative in front of C, it's going to go to the right. So it's going to go right 2, and then D has a plus in front of it, so up 1. So then transformations are right 2, up 1. But then we have a negative, so that means it's going to reflect over the x-axis. Reflect over x. And now, let's copy the table, the parent function table. So here we have the parent function table. Now all we have to do is change the sign of the y values because we have a negative in front of the absolute value. So then this becomes -2, -1, 0, -1, and -2. All right, so let's plot those points. So I'm going to cross out this column, okay? So then let's go right 2, 1, 2, and then up 1. So we're going from this point now. And then connect the other, plot the other points. So from here, left 2, down 2. There's that point, left 1, down 1, right 1, down 1, and right 2, down 2. Then connect the points. And there is a graph with the transformations stated here. Domain, as I said, it's not going to change. So x is all real numbers. The range, however, changes with the value of D and also the value of A. So y such that y, notice this now opens down, so less than or equal to, then the maximum point, which is the vertex point, is where y is 1. So there we have those last 2 examples for this lesson. Okay, last part. Write an absolute value function matching the description. So the parent function f of x is equal to the absolute value of x. In its translate, it's 12 units up. So that means you have plus 12, which means you have plus D, that's a D value. And then 6 units left. So then you have minus, it goes left, so then this will be plus C. So you have minus 12, okay? So then this is what it looks like. So I have f of x is equal to, I have minus 12 inside of the absolute value, so we have x. This means plus 12, right? So then this is x plus 12, okay? Oh, not true. This is not true, right? Because I'm looking at the wrong question here, looking at the wrong information. So 12 units up, we know 12 is going to be outside, so plus 12. And then C is 6, so this should be a 6, not a 12. I apologize for that mistake. So we have plus 6. So this means the graph goes to the left 6 and then up 12. And that's the function that has those transformations. Okay, last example. So for this one has a vertical stretch. Okay, so factor of 8. So that means A equals 8. And then translate it 7 units down. So D equals -7. And then 3 units to the right. So that means C equals 3. And it's going to have a negative in front of it. And it's reflected over the x-axis, which means this is -8. Okay. So then f of x equals -8. That's the a value, absolute value of x. The graph is going to go to the right. So it's going to be -3. And then d value is -7. So that's the function that represents the transformations that we're given. All right, thank you for watching. I'll see you in class. Bye-bye.